Hi, boys and girls. Today we're doing lesson 6.4 in your book. If you don't know where that is yet, please stop the video and find this lesson in your textbook so that we can go through this. All right, thank you. So today's objective or essential question is how can you transform units to solve problems? Here's our objective right up here at the top. Okay, so that word transform means to change, okay? When you transform something, you change it. So you can sometimes use the units of quantities in a problem to help you decide how to solve the problem. Okay, so this is a problem solving lesson that we have, and there's some difficulties, some things that could be a little harder to understand. Before we get started, I really wanted us to think about units when it talks about units of measurement. Okay. Um, and we're going to be looking at something called a rate. Do you remember what rates are? R-A-T-E. So rates are like 50 miles per 1 hour. Like you can drive 50 miles in 1 hour. They have two different units of measure. This is distance, and this one happens to be time. Okay, so that's what a rate is. So we're going to be working with rates in this particular unit. So really think about that today. Rate. Okay, I'm going to erase some of this so I have space to work. All right, so let's take a look at the problem that we have in our lesson today. It says a car's gas mileage is the average distance that the car can travel on 1 gallon of gas. Okay, think about that. Your car can go 28 miles per gallon or 10 miles per gallon, whatever. Our cars are all different. Okay, my truck can do 20 miles per gallon. That's just typical. All cars can do that. This is kind of that same kind of problem. Marla's car has gas mileage of 20 miles per gallon. Hey, that's just like my truck. Whoops, I just erased that. Okay, how many, now here's what we got to solve, miles can she travel on 9 gallons of gas? So first of all, before we even do anything, ask yourself, what do they want me to find? How many what? Miles. So I'm looking for miles. Okay, that happens to be a distance. I want to know how far she can go. Okay, so the first thing you always need to ask is you have to get that perspective of what do they want me to answer before you can solve the problem. Now let's take a look and analyze our problem here. Okay, first of all, we're going to identify the units. The vehicle can go 20 miles per gallon. Per means for one. Okay, for one. So that would be 20 miles miles per gallon. That's our rate. Okay, here is our rate right here. Okay, now the amount of gas is 9 gallons, right? So I want to know how far miles she can go on 9 gallons. So my answer is going to be a distance answer. So to solve that, let's go on down here to step number 2. We're going to determine the relationship, which we've kind of already done. We know that we've got miles per gallon, okay? Now we're going to use that relationship now in step 3 to answer the question. We have 20 miles per gallon. Now I want you to notice how they've set this up. 20 miles per gallon times 9 gallons. Do you remember doing this when we did conversions? It's kind of the same kind of situation. Okay, now you notice gallons is on the bottom down here. Do you see that? All right, so gallons, when I set this up, has to be on the top. That will help you also. We want them to be catty corner from one another, okay? So when I multiply by a whole number, I have to put it over 1. That's why they have 20 over 1 is equal to 9 over 1. So let me rewrite that right here. 20 over 1 times 9 over 1. This is minus the labels real quick, okay? But we know that this is gallons. We know this is gallons. So we know that they're across from each other, right? All right, so that means I have 20 times 9, which is 2 times 9 is 18. Add that 0 over 1, which means Maria can travel 180 miles on 9 gallons of gas. Okay, I kind of went through that quickly. Just remember, this is the key right here, is how do I set this up? How do I set up this problem? Okay, just remember you've got your labels are opposite one another, just like when we were converting units of measure. All right? All right, let's go to the next page. Turn as I do. Okay, we've got another problem here. Now, this one's harder, and the reason I'm doing it on the video is because I think it's important that you understand some of the elements that are in this problem today. Okay, let's just read the problem. I wrote a formula up here for you. A formula is a set rule that never changes. So we've done area before in 5th grade or 4th grade. We know that it's length times width. Okay. The material for a rectangular awning, this thing right here is the awning, okay? It has an area of 315 feet. I know the area is 315. It's going to equal something times something. Okay. If the width of the material is 5 yards, what is the length of the material in feet? Okay. What are they asking me for? Well, let's just read the parentheses. Recall that the area of the rectangle is equal to its length times its width. And that's what they're trying to show you right here. Okay. 315 is supposed to be equal to the length, okay, times the width. Does this make sense? Length times width tells me what's in between here. Okay, so we have length times width. Now, this is feet, if you remember. One of our pieces of information, our width over here, or I'm going to put a little W up here, is 5 yards. Okay, we've got a problem here. Are feet and yards the same thing? Are they? No, they are not. So before we can solve this, I have to change one of these numbers or values so that it's easier to work with. I don't know what the length is. I'm solving for the length. That's what they're telling me to do right here in the question. Okay, I'm solving for length. So what I'm going to have to do, first of all, is I need to take this 5 right here, and I'm going to come down here to step 2, and I have to convert it to feet. Okay, so I have 5 yards times, how many feet are in a yard? Let's see, I believe there's 3 feet in a yard. Remember that? Okay, so yard and yard, remember they're opposite from each other. So now I know which way I can set up the problem. So 5 times 3 now is 15 feet. So 5 yards is equal to 15 feet. Okay, so now I can come over to my problem and I can put in 15 feet. That's his feet, right? This one's feet. Times something is going to give me the length in feet. Now, we haven't done a lot of algebra yet, so this is where this gets hard, boys and girls. To solve this problem, we're going to have to do the opposite of multiply. We're going to have to divide, okay? So let's go over here to their step 3 real quick. It says 315 square feet divided by something. Okay, so you're going to do the opposite. We're going to take this value, instead of multiplying it by, I don't know, I'm going to make it an L. I'm going to do the opposite. Okay, I'm going to divide 315 by the 15 feet. Okay, when I do that, when I do the division, it's going to give me the answer. Okay, so let's take 315, some space here first. Let's take 315 and we're going to divide by 15. Okay, so 15 goes into 31 2 times. Okay, it's supposed to be a 2. That's 30. That gives me 1 left over. Bring down my 5. 15 goes into 15 one time. Now, I don't have room, but my answer is 21. Okay, so this, I'm just going to fill in what they have here. 315 divided by 15. So we have 315 divided by 15. The answer was 21 feet. So the answer in this question is 21 feet. All right, boys and girls, what was different about today's problem is I had 2 different units of measure. I had yards and I had feet. It cannot be, this cannot be, if you come up against this again in another problem. You're going to have to do a conversion first, so that every one of the label pieces are the same, okay? Or the measurements are the same. All right, boys and girls, happy math.